So today we're stepping back into the P chapter for a brief run through on solving inequalities. Now I'm not going to go all the way back and explain every little detail. Primarily I'm just going to explain it in the context of solving inequalities. So if you need additional instruction, then we can talk about that in the Math Center, or you can look also in the P2 section of your book. There's a more detailed explanation. But I just wanted to do a quick run through of just reading these inequalities. So each one of these reads a little bit different. This one says x is less than 2. So it's either less than or greater than, and then it's whether it's the equal is set or not is whether or not this extra line is here. So just a reminder that the larger number is always on the mouth of it. So basically the 2 means it should be bigger. So the way that I just want to show a graph of what this would look like. X is less than 2. So we just have our number line. We don't have x and y, so we just have basically our x's here. So here is 0 in the center. And so we're looking at 2. So x is less than 2 looks like the solutions are, so 2 is not included in this. So I use an open circle to say 2 actually isn't, I'm not allowed to use 2 as a solution in this. And then all numbers that are smaller than 2 are in this direction. So if I wanted to graph it on the number line, it would look like this. Okay. All right, so the next one is red. X is greater than 2. Okay. And so again, I'm going to draw my picture. 0 here, 2 here. So again, 2 is not included because it does not include the extra line underneath that says that it would be equal. So I have an open circle on the 2, and then I'm looking for all numbers that are bigger than 2. So that would be to the right of 2. Now these 2 on the bottom here are very similar to the 2 on the top. This one here is read as x is less than or equal to 2. So this time, I draw my same picture. Here's my 0, here's my 2. This time, when I'm looking at 2, 2 is a solution to this particular one. Here, I'm making them a little off here, but so this time I'm going to fill in my 2. Graphically, that means the 2 is included. So now I want the 2 and everything smaller than 2. Right? So these 2 here, right, look very similar to each other. The difference is, though, here the 2 is included, here the 2 is not. And the same goes with this graph here. It'll look very much like this one here. These 2 should look alike. The only difference is this one is read x is greater than or equal to 2, so that means the equal to 2 is also allowed, and so that's the difference. So these 2 and these 2 are very similar. The only difference is when I have this extra equal sign, then that actually means that I can include the 2. Now most students can tell me that when I'm solving an inequality, basically I just treat the inequality just like it were an equal sign. So as long as I'm doing things fairly, I mean I'm adding the same thing to both sides, I'm dividing by the same thing, for the most part it works, except there's a couple of cases, okay? And that is division by a negative number or multiplication by a negative number. So I'm just going to, this doesn't constitute proof by any way, but I want to just show you why some of this works. Okay, so let me just start with an inequality that does work. So I have 4 is greater than 2. So let me add a positive number to both sides. Let's say I'm going to add 2 to both sides. If I add 2 to 4, I get 6 is greater than 2 plus 2 is 4. This is still true. Okay? So let me move to this. So this I added 2 here. I added 2. So let me instead add a negative number to both sides. So let me, or I can think of it as subtracting 3 from both sides. It's like I'm adding negative 3 or subtracting 3 from both sides. So in that case, I'm going to get 3 is greater than 1. This is still a true statement. So I'm just trying to illustrate that I can add and subtract whatever I want from both sides. Then this inequality will hold. Right? If I have a number that's bigger than another number, then as long as I'm adding or subtracting the same number from both sides, that inequality is going to hold true. Right? So the same kind of goes with multiplication as long as I'm in the positive. So let me start with my 4 is greater than 2. So let's multiply both sides by a positive number. So I'm going to multiply this side by 3 and this side by 3. So then I get 12 is greater than 6. This is still true. Let me multiply by, let's see, how about if I multiply by a half? So let's multiply by a fraction. Again, I get 6 is greater than 3. This is still true. Right, so far multiplication hasn't been an issue. However, let's multiply now by -2. Then I get -12 and -6. And now if I try to put my inequality symbol in here, my inequality doesn't hold anymore because actually -12 is smaller than -6. So this is why we end up switching the sign. So really this should read -12 is less than -6. So when I'm multiplying by a negative number, and it also happens when I divide by a negative number as well, I need to change the direction of my sign. Now in a lot of cases I can actually avoid dividing by a negative number. So let me just walk into our first example here. All right, so we're just going to kind of run through all the different types of equations that we solved right now, only this time we have inequalities. All right, so one way that I could solve this, all right, so I have this inequality here. As long as I'm adding, subtracting, or multiplying by a positive number, or dividing by a positive number, then I treat this just like that inequality symbol was an equal sign. So let me subtract 2x from both sides. When I do that, I end up with -5, the inequality symbol's still here, greater than, then I get x plus 7. So now I want to get x alone, so I'm going to subtract 7 from both sides, and I end up with -12 is greater than x. Now typically we like to write it the other way, so I'm going to write this as x is less than -12. Right? The inequality symbol, I've got it going the opposite way, but I've written it backwards too. So since the small tip is facing the x, I've got the same thing here. So this is read x is less than -12. Now I could have done it another way, right? There's multiple ways that you can go about solving equations. So what if I had 2x minus 5 is greater than 3x plus 7, but this time maybe I really like to keep my x's on the left hand side, so this time I can subtract 3x from both sides. So now I have -x minus 5 is greater than 7, and I add 5 to both sides and I get -x is greater than 12, right? I'm adding 5 here and I'm adding 5 here. Now I don't have x alone. I need to really divide by -1. And now this is a case where in order, you see, I'm going to have to flip my sign to make it match. X is, since I divided by a negative number, 12 divided by -1 is -12, but I need to flip my sign. So here and here I get the same exact answer. Here I managed it without dividing because I kept my x's positive, and here to get the same answer because I didn't move my x's to the positive side, I end up with this value. So it's only when I'm dividing by a negative number or I'm multiplying by a negative number that this happens. All right, so let's move into absolute value inequalities. Now, there are multiple different ways that you can solve absolute value inequalities, but for consistency's purposes, I teach it kind of like this, okay? So what I do is instead of this less than sign, this is read as the absolute value of x minus 3 is less than 7, I think of it like this. The absolute value of x minus 3 is equal to 7. Right? So I'm going to, in typical absolute value fashion, drop the absolute value bars and set it equal to the positive and negative version of this. Okay? So on the right I get x equals 10. Or, I'm sorry, this is the left, right? I add 3 to both sides, here and here. I end up with x over here, and 7 plus 3 is 10. And then on the right, I'm adding 3 again. This time I get x equals -4. So what I like to do in these cases is I like to put them on my number line. So here's my -4, maybe here's 0, and then 10 will be way up here. All right, so I know so these are places, if I check them, these are places that equal 7. Now that's not exactly what I want here. I want less than 7. So I know that because this is less than, these two numbers are not included. So I'm going to circle my two numbers. Okay? So now what I'm going to do is I'm going to check in each interval. So if my graph, right, is going to change, it's going to change at these places. So it's going to hold basically whether it's true or not true in each one of these intervals. So I'm going to take a test point in each one of these intervals and see where it's true and not true. So I just need to pick one point in each one of these intervals on my number line. So this is my -4 and my 10 my number line into 3 pieces. So this is my testing. Let's test when x equals -6. So I'm looking to see if my inequality holds true. So my solutions are where my inequality is a true statement. So I have the absolute value of -6 minus 3 is less than 7. And I'm looking, is this true? So this actually becomes the absolute value of -9 is less than 7. And the absolute value of -9 is actually +9, which is not less than 7. So this is false. Right, so I'm going to write false up here so I don't think, right, this is not part of my solution here. All right, so let me test a number in between -4 and 10. So I want to test something in here. Well, whenever I come across x equals 0 in there, I usually try that because that's a nice, simple one to try. So when I plug in 0, I'm plugging it back into here. Then I have the absolute value of -3 is less than 7 because I have 0 minus 3. Here, this ends up simplifying to 3 is less than 7, and this is true. So this piece here is part of my solution. Okay? So now the last thing I can check is a number that's bigger than 10, so let me try 12 for instance. Right? I can pick any number bigger than 10, just not 10. Any number bigger. So I have the absolute value of 12 minus 3 is less than 7. I'm looking, is that true? And I get the absolute value of 9 is less than 7, which is a false statement, right? 9 is definitely larger than 7. So this is also false. So my inequality, right, when it's written like this, I can write it as an inequality as x is between 10 and -4. Now I don't use the equal signs because this original one didn't have the equal, right? So I'm not going to use them here. All right, so let's look at this other piece over here. I'm going to solve this like it's x plus 2 equals 9. So that gives me x plus 2 is 9, and x plus 2 is -9. So I'm going to have x equals 7, and x equals -11. A quick check shows me that these actually do work, right? Because these are sometimes absolute value do give me extraneous answers. So my number line then, so I have -11 out here. Maybe I'll put my 0 here, so my 7 should be a little closer. So this one, when I'm looking at my inequality, it's greater than or equal to 9. So that means that solutions that give me 9 are in fact usable in my equation. So that means that the 11 and the 7 will be included. So I'm going to fill those in so I don't forget. All right, so now I'm going to test a point in each interval. So I'm going to test something out here. Let's say I have -12 is a nice number. And so if I put in -12 here, back here I get -12 plus 2, which is -10. And 10 is, because I take the absolute value of -10, 10 is greater than or equal to 9. So this is true out here. So I'm just going to put a t this time. So that means that this piece is a solution. All right, so now if I look at the 0 as my test point, I'm going to plug in 0 here because I'm just going to pick something easy between -11 and 7. If I really wanted to, I could use a half, but I'm going to pick what's easy. So I put in 0. 0 plus 2 is 2. Absolute value of 2 is still 2, which is not greater than or equal to 9. So this is false in here. All right, so now I'm going to choose a number bigger than 7. Maybe I'll just choose 10 because it's easy. So if I choose x is 10, then I get 10 plus 2, which is 12. Absolute value of 12 is still 12, and 12 is in fact larger than or equal to 9. So this is also true out here. So this is what my inequality looks like. And so I can write this as either, right, this has 2 sections, right? So if they're all together, then I can write it like this, right? X is between these 2 numbers. But this is 2 different pieces, so I can say that this piece would be x is greater than or equal to 7, and this piece would be x is less than or equal to -11. So I can put an or between them. So this is my solution here. All right, so that's absolute value. Again, if you need more practice with these, there's a lot of them. There's several of them in the book, and we will do some in lab as well. All right, so let's look at the last type that we have solved. I mean, we're just normal equations, what we've solved so far, right? We've done absolute value, we've done linear, and now we're going to get into some polynomial inequalities. And again, we attack this very much like if it were x squared minus x minus 12 is equal to 0. So that's what we want to think about first. Okay? So the way that I would normally solve this, right, I have my choice of 4 different methods. I'm thinking factoring will work very nicely for me here. This factors as x minus 4 and x plus 3. So the first thing I want to do is find where my function is equal to 0. So at x equals 4 and x equals negative 3, I am going to get, right, these are places where my function is equal to 0. Now when I put these on my number line, just like with the absolute value, I come back here to this sign. This says greater than 0. So because there's no equal to 0, that means that 4 and negative 3 aren't actually solutions to my problem, but they are important numbers for me. So let's see, I want this, I'll make this 0 here. So I'm going to put circles around my numbers because I know that they're not included, but I know that they're important to me. So this particular inequality, saying that it's greater than or greater than 0, means that what I'm looking for are positive numbers. Okay, numbers that are bigger than 0 are all going to be positive. And so numbers can't go, if you think of a graph, right? My graph can't go from positive to negative without crossing over this line here that's 0. And so we're going to use that idea. So basically we're going to do just like we did for the absolute value inequalities, and we're going to check a test point in each interval. So let me use, for my test, I'm going to choose x equals negative 5 here. Okay. Now I always go back to this, because this is a nice way, because I know that when I multiply two positive numbers I get a positive, and really all I want to know is the sign, right? Because if it's positive, then that's part of my solution. If it's negative, then it's not, because this is greater than. So greater than 0 means I'm looking for positive solutions. So I don't really care what the number is when I put it in. I only care about whether it's positive or negative. So let me try x equals, x is greater. I don't know what I'm talking about here for a second. So I'm going to test x equals 5, okay? And so what I'm going to do here is I'm going to put in negative 5 in here and just look at it. So I have negative 5 minus 4 times negative 5 plus 3. So this is going to be negative, right? It's going to be negative 9. And then this is times negative 2. And just so happens that a negative value times a negative value gives me a positive value. And so that means I have this piece right here that is in fact true. All right, so if I plug in 0, I'm going to plug in 0 into my factors, right? That's what I'm doing here. So I have 0 minus 4 times 0 plus 3. And this is going to give me negative 12, which is not positive, so this is not part of my solution up here. Now a number bigger than 4 gives me, let me just use x equals 5. I have 5 minus 4 times 5 plus 3. Again, it doesn't matter what that number actually is that this is negative 12, just that it's negative. So here I'm going to get 1 times 8, which is 8, but the only thing that really matters is that it's positive 8, right? That's the thing that matters. And so that means that my solution falls here as well. So I could write this solution as x is less than, or yeah, just strictly less than, because of this there's no equal to. X is less than negative 3 and x is greater than 4. So here's my solution. All right, I didn't plan very well here, so let me write this one that I have written up here instead. So let's see what happens if I just have the less than or equal to. So up here we solved, it was the same quadratic that was greater than 0. Here I have the same quadratic, but just this time less than or equal to 0. All right, so again, I'm going to go about solving it just like it was an equal sign, because these zeros are sometimes what we call critical numbers. They're important numbers, where So we're going to factor it, and it doesn't factor any different than what we did before. Okay, I'm going to put my zeros on here. They are -3. There's my 0, so my 4 should be a little bit further away. This time, this symbol means I have an equal to sign. So actually the places where it is equal to 0 are part of my solution. So that means that now the -3 and the +4 are included. Now this one is less than 0. So this is where I'm looking for negative values. Now, the reality is that if these are where the positive values are, then probably it's this middle piece in here. But we'll just go through the process of just checking here. So if I check out x equals -4, I'm going to plug them in here, right? So -4 minus 4 is going to give me a negative number. So I'm just going to write a negative. And then -4 plus 3 gives me a negative number, which then a negative times a negative gives me a positive number. And I'm looking for negative numbers this time. So this is a positive, so this part is false, right? Or I often put like the sign of it up here, like this is positive because I know I'm looking for something negative. All right, so if I plug in x is 0, then I'm going to get a negative number because I get -4 there. I'm putting it back into my factors. I plug in 0 here and I'm going to get a positive number, +3 in fact. But all I care about is that the negative times the positive is going to give me a positive result, right? So this is the true space in here. So I know that this will be part of my solution. Then the last thing I can do is check for x is +5, and when I plug in 5 here, I get 5 minus 4, which is 1, so it's positive, and 5 plus 3 is 8, which is also positive, and positive times positive gives me, in fact, a positive answer, and so this is a false spot because I am looking for negative values because this is a less than. So my solution this time, when they're connected, I can write -3, I've got the x and I've got the 4, right? This is the largest, and because of this equal, these also have an equal sign as well. All right, so let's look at that quadratic that I put in it's not a quadratic, but a polynomial. I put it in a bad spot there. This I'm going to give us already factored just because. Right, so we can use this idea even on, this isn't a quadratic because if I multiplied this all out, right, just this would give me a quadratic. And then if I multiply through one more time with an x, I'm actually going to get an x cubed as my highest power. So this is technically a cubic inequality. It is already factored, and so I thought we could try this out. It's exactly the same procedure as the quadratic. We first find the zeros. So we have x equals 0, x minus 2 equals 0, and x plus 3 equals 0. We're technically solving this. We're looking at where is this true first, okay? This gives me x is 0, x is 2, and x is -3. So I'm going to put these on my number line. So I'll put my 0 here first. I'll make that the 2. -3 should be a little farther away. All right, so this is greater than or equal to 0. So let's think about this again. So that means that places where it is 0 are going to make it true. So that means that my 3 solutions that I found so far are part of my solution. And then greater than or equal to 0 means I'm looking for positive answers. So now my number line is actually broken into 1, 2, 3, 4 pieces instead of 3. So now I need 4 test numbers. So let me use x equals -4 to start. So I'm going to test something in this interval, something smaller than -3 that's not -3. All right, so I'm going to plug it right back in here into the factored version. So I'm going to have -4 times -4 minus 2, and then -4 plus 3. And I'm checking what's the sign of this. So this is going to be negative, right? That's -4. This is also going to be negative. I'll just leave off the 6. It's -6, but all I care about is it's minus. And then this one is also -4 plus 3 is also negative. And when I multiply a negative times a negative times a negative, I get a negative number. So I'm going to put the minus up here. So that's the sign of my value. That is not what we're looking for, right? So that's not, this interval here is not part of my solution. So let me look at something between -3 and 0. let me try x equals -1 is a nice one. All right, so if I plug that in, then I'll have -1 times -1 minus 2 times -1 plus 3. Right, so this will be negative, right? That's a negative piece. -1 minus 2 is still negative, and now -1 plus 3 is actually positive. And so now I have these two negatives make a positive times this positive is positive. So in this interval, I end up with positive. So that means that this is in fact part of my solution. So I'm going to go ahead and color that in. All right, so now I need a number between 0 and 2. So 1 is the only integer between them, so let's try out x equals 1. I'll put this over here. All right, so I'm putting it back again into this piece right here. And so I have 1 times 1 minus 2 times 1 plus 3. So this is positive 1. This is negative, right? -1. And then this is positive. And so I have a positive times a positive, which is positive, but then times this negative is negative. So it's negative in this interval. Okay? Not part of my solution because, again, I was looking for positive numbers. If this had been less than, then these would be part of my solutions and this one would not. All right, so now I just need a number bigger than 2. So last part, I'm going to pick a number in here. I'm just going to use 5. Why not? I could use x as 100 if I wanted to. All right, so now I'm going to put in 5, that's my x, times 5 minus 2, times 5 plus 3. This is positive, this is positive, and this is positive. And when I multiply 3 positive numbers together, I'm going to get a positive value. And so here is my other piece of my solution. And so I write this then, I can write this as two inequalities, right? I can say that x is between 0 and it's equal to because of this symbol up here, right? I've got an equal to sign. So x can be between -3 and 0, or x is greater than or equal to 2. And those are my solutions. So the more zeros that I have, the more intervals that I have to test. All right, so if you have any questions about inequalities or if you want more examples, please refer to your P2 section.